Hi there everyone and welcome back to the channel. I hope none of you are allergic to bee stings because today we're going to be taking a look at the brand new Acrobee75 V5 from Newbeedrone. This features the brand new Beebrain flight controller that's just been released, as well as some features that you've probably never seen on a 75mm tiny whoop before, or at least I never have. In this video I'm going to be taking you through all of the key features of this little drone on the bench. I'm going to be measuring the output power of the VTX, and we're going to be putting all of that data together to answer the question: is this your next 75mm tiny whoop? Is this the best one you can buy today? It's a lot to cover in one video, so let's not waste any more time. Let's dive right into it. Alright, so let's take a look at the Acrobee75 BLV5 on the bench. And let's start with the frame and canopy. So this is using the Newbeedrone cockroach frame, which comes with a lifetime warranty. And it's nice and flexible and looks like it's going to be pretty durable. And if they offer a lifetime warranty, then I imagine they're pretty confident in the durability of it. We have the Goober canopy, and this again looks like a very stiff polycarbonate canopy, and it has a camera in here. This is the Runcam Nano 4 with adjustable up tilt. So the Runcam Nano 4 is a really good small size camera. It's got a nice big lens assembly, and you get good performance both in daytime and low light. And obviously when I do the flight footage, you'll see how the camera looks. It is an analog camera, but it's a good quality one. So we are going to get hopefully some nice video out of it, and I'll show you the DVR later. Then we have the motors. These are pretty big motors. These are 0804 14,000 kV motors, and they're driving a 40mm tri-blade prop. Now, an 0804 motor with 14,000 kV means that you are going to want to fly this drone on 2S battery voltage. 14,000 kV is too low for a 1S battery. And this is a pretty big and powerful motor for a 40mm prop like this, so we'll have to see how it performs on the flight test. I did notice that they've decided to connect the motors with a JST 1.0 plug to the flight controller. Now, I've spoken to a lot of tiny whoop racing pilots who, even on 65mm tiny whoops, say that they see a significant loss in performance with a JST 1.0 plug like this, which means that a larger 0804 motor on 2S, almost certainly you're going to have some voltage drop and some performance loss with this plug. And if you're concerned about that, you may want to just cut this plug off and direct solder the motors onto the solder pads that are on the top of the board here. That's certainly what I'm going to be doing, and that's what I would recommend. Obviously, I'm going to do all the test flights with the motors on plugs as it's shipped, but I think once I finish this review, I'm going to be cutting the plugs off and direct soldering onto this board. Flipping the drone over, we have a 1mm carbon fiber plate to add stiffness to the frame. That's a really nice idea. I think even, normally I would say that 1mm carbon fiber is quite flexible, and there is still some flex in this frame, even with the 1mm plate. Let's see how it performs on Blackbox log analysis before we give a final conclusion on whether this plate is thick enough or whether it's necessary. But it's nice to see that they're definitely thinking about vibration and resonance, and they're including this carbon fiber plate to try and improve that. We also have a little 3D printed battery holder here, flexible one, and that's attached to the carbon plate by 4 M2 screws. You're going to want to check that your battery is going to fit in this little holder. And in terms of sizing, if the battery is about 12mm by 15mm or so, then it's going to fit really nicely into this flexible TPU battery holder. If not, you're just going to need to maybe print a slightly larger battery holder, or you could also remove this and attach the battery using some Velcro tape or something like that. The XT30 on this bind and fly is quite long actually, and the wires are not all that thick. So I'm just a little bit concerned that this pigtail might be a little bit too long and might waggle around, and also that the wires are quite thin. If I compare it to a couple of 2S batteries that I've got, they have slightly thicker wires for the battery cable than the XT30 on this drone, so I would have liked to have seen it perhaps a little bit shorter. There's still plenty of length on the battery connector to connect this up, even with a slightly shorter pigtail. We don't necessarily need all that length. In terms of antennas, we've got quite an interesting antenna setup, and I think this is pretty unique on 75mm whoops that I've seen. We've got a little whip style VTX antenna on the top, That's for the 5.8 gigahertz VTX, which goes up to 400 milliwatts of output power, and we're going to be testing that later on in the video. We have a 2.4 gigahertz Express LRS T-style antenna at the back, and you can see that it's got this nice little clip built into the frame to hold the antenna, and a little cable tied to secure it here as well. But then we also have another whip-style 2.4 gigahertz antenna that's connected to the bottom of the flight controller. So this appears to have a Diversity 2.4 gigahertz Express LRS receiver and 2 antennas. I'm not sure how necessary this is for a little tiny whoop like this. I'm pretty sure you're going to outrange the 400 milliwatt VTX long before you run out of range on your Express LRS 2.4 gigahertz control link. But it is interesting to see that they're adding this feature and having an extra VTX antenna so that we have a T-style and a little whip antenna, both connected to the flight controller by U.F.L. connectors. Again, looking around on the top of the flight controller, I can also see that they have a little capacitor here. This is a 25 volt 100 microfarad capacitor, and I think 25 volts is definitely overkill for a drone of this size. You're only going to be running this up to a 2S battery, which is 8.4 volts fully charged. And going for a higher voltage rating on your capacitor means that the capacitor is larger and heavier than it needs to be. You could have got a 10 volt 100 microfarad capacitor, and that would have been, well, about half the size of this 25 volt capacitor. Or you could have gone for something like a 10 volt 200 microfarad capacitor, which would have been the same size and weight, but had a larger capacitance. So when you're choosing capacitors for your builds, make sure that you don't choose a voltage rating that's higher than you need. If you're running 6S, something like a 35 volt capacitor is more than enough. And if you're running 2S, something like 10 volts is more than enough. You just want to be slightly above the voltage of a fully charged battery. And then that's going to mean that you get the lightest weight capacitor for the amount of microfarads for the capacitance that it has. So let's get some weights for this Acrobee. So the dry weight is 36.47 grams. And if you fly it with a 2S for 50 milliamp hour, that's going to come up to about 58 grams. And if you choose to fly it with a 2S 750, which is about the biggest that you can go, that takes it up to 71.8 grams. So now that we've been through all of the bind and fly features, I'm going to take this apart so we can have a look at the flight controller in some more detail. All right, so now that I've taken the flight controller out, we can look at this in more detail. And you can see it's a very, very busy board here. We have an STM32 G4 processor, so that's going to be plenty fast enough to run a 4K PID loop in Betaflight with all the bells and whistles switched on. We've got the U.F.L. for the VTX antenna. We have a plug, but also pads for the camera, so 5 volt ground and camera. We've got pads for the motor outputs, so you can direct solder the motors, and I would recommend that you direct solder the motors rather than using the plugs, because you will lose some performance due to voltage drop in the plugs. We've got a couple of free UARTs, one there and one here, I think, on the underside, although these pads aren't labeled. So hopefully when this board is officially released, there will also be a wiring diagram showing where those free UARTs are. We've got the little 2.4 gigahertz antenna on the bottom, and this 2.4 gigahertz antenna connection on the top. Now, it's probably really hard for you to see, but one of the challenges with these tiny connectors is I went in with a pair of tweezers to try and just disconnect the U.F.L, and I pulled the connector off the board. So these super small, this is like a smaller than usual U.F.L connection. That's a standard size one here for the VTX, and that was absolutely fine, just lifted that off, no problem. When I went to lift this connector off, I just pulled it straight off the board, and the whole connector just exploded basically because it's so tiny, just cracked into several pieces. So I would say if you do get one of these flight controllers and you plug in the antenna, don't ever unplug it. This is a single use connector. You plug it in once and you leave it connected forevermore. You never disconnect it. If you try and disconnect it, there's a decent chance you'll rip it straight off the board. So that said, let's connect this up to Betaflight and have a look at the configuration that Newbeedrone have put on here from the factory. One thing that I do like about this design is how easy it is to get to the USB port underneath. You can pretty much just slot the USB cable straight through between the carbon plate and the little battery holder, and it just plugs in really nicely. And that's a really nice attention to detail feature. All right, let's run through the Betaflight configuration that comes on the Acrobee75 from Newbeedrone. And we're going to start by looking at the gyro. This is got an MPU 6000 gyro. Now I'm going to do another video about the MPU 6000 gyro and some of the problems that I faced with it recently. Overall, my advice to you, to all manufacturers, is to move away from the MPU 6000 to a newer gyro. Ideally, something like the ICM 42688 is a good one. The BMI 270 is also great, especially if you can't run an 8K PID loop, then the BMI 270 is fantastic. 3.2K, spot on. The MPU 6000 is starting to have problems now, and I'll explain more about that in another video. Moving on to the ports, you can see we've got the internal Express LRS 2.4 GHz receiver connected up to UART2, so that's internally connected. That's good. That means that the Express LRS receiver is on a serial interface, which means that you can update it separately from Betaflight and always be on the latest version of Express LRS. That's really, really good to see. Moving on to the configuration, we have an 8K gyro and a 4K PID loop frequency. That's correct for a G4 flight controller. That's as fast as it's able to run. The G4 is almost exactly the same speed as an F405. So you can run 8K, 4K perfectly, but you won't be able to run 8K, 8K with a G4 processor. We have a maximum arm angle here of 25 degrees. That's probably okay. You may have difficulty arming if you've flipped upside down. So I would normally set the maximum arm angle to 180 degrees. That way you can always be sure you can arm the drone so you can turtle mode and flip it back over. All the other configurations look sensible. We've not got any D-shot beeping set up, and if you want to have the motors beep to tell you where the drone is, particularly if you're flying outside, then I would set that beacon tone to 3 and turn on RX lost and RX set so that it's going to beep when you tell it to, or if it loses radio connection. Now let's jump into the PID tuning tab. And for PID tuning, we have a custom PID tune on this. The custom PID tune has dynamic damping turned off and feed forward turned way down. But otherwise, pretty much everything else is set at default. Pitch tracking is turned up a little bit to 1.1, and we have the master multiplier turned up to sort of tighten everything up. Hopefully this drone has Blackbox, and then I can take a look at this tune, but we'll have to check that later on. Dynamic damping is off, so it doesn't matter that that's not set correctly. You always want advanced set to 0 on dynamic damping. So looking at the throttle and motor settings, I can see that Newbeedrone haven't set a dynamic idle on the Acrobee75. You are going to want to set a dynamic idle to get the best low throttle stability. And for a 40mm tiny whoop like this, something around 90 is what I would recommend. So it's a lot higher than you'd have for a 5-inch, which is typically, maybe 30 to 40. But for a really small prop like this, you're going to need to set that much higher to make sure that the motor RPM doesn't fall too low and you lose control of the quad at low throttle. And then you get kind of wobbles and prop wash at low throttle. We have battery sag compensation on, so that will adjust the PID settings as the battery drains. I think that's fine. And we have thrust linearization, which we do definitely want for tiny whoops. It just helps, again, kick those motors out of that low RPM zone more quickly, so you get better responsiveness at low throttle particularly. Everything else looks pretty sensible here, so we'll save that. Looking at the motors tab, you can see that we have the motors set in the kind of standard props in configuration. That's not the best for tiny whoops. You get a lot of benefit actually from switching to props out with tiny whoops, because that's going to give you more control, particularly in sharp spirals. And if you're racing, it's really recommended that you run props out. So I'm going to be changing this over to run props out after I've done this review, but I'm going to test flight obviously in the standard configuration, so we're going to leave props in. D-Shot 300 is reasonable for a 4K PID loop, that's correct. And everything else looks sensible. On the VTX, we've got VTX remote control on this drone, and it's over, I think, a SPI interface. So you can choose your channel band and power, and we have 25, 100 milliwatts, or max, which is up to 400 milliwatts. but that maximum power is going to depend on the cooling that we have on the drone. And of course, I'm going to be testing what the output power of the VTX is, so that you can see whether it lives up to this 2500 and up to 400 milliwatt claim. Now let's take a look at the black box logging. And unfortunately, the Beebrain BLV5 doesn't appear to have any black box logging on board. So there's no black box chip where you can log your flight data. And what this means is that you're not going to be able to debug the quad if there's any issues, and you're not going to be able to do anything about the tune. You're not going to be able to improve the tune really without black box log analysis. So if you're someone who just likes to pick a quad up and fly it, and you never want to make any changes to the tune, you never want to do any debugging, and if it doesn't work, you're just going to send it straight back to Newbeedrone, then I think this is okay. If you're someone who wants to get a little bit more into technical detail, wants to try and dial in the tune to have the quad flying even better, then you're not going to be able to do that without black box logging. And that means that you're going to need to either add like an open lager chip on a UART to do logging, or you're going to need a flight controller that has a black box chip built into it. So let me take you quickly through the test setup that we're going to use to measure the VTX output power and show you one of the interesting features I noticed of this Beebrain flight controller. We've got the flight controller powered from a power supply set to 7.4 volts, so standard 2S battery voltage. And you can see that we have a fan blowing on the flight controller all the time to keep it cool, so we should be getting close to the maximum output power that it can deliver. The output from the VTX is connected via this U.F.L to SMA adapter into a 30 decibel attenuator and then into this ADL5902 true RMS RF power meter. That converts the RF power into an analog voltage signal, which is measured by this Arduino and displayed up here. You can see we're getting 1800 millivolts, or just 1.8 volts coming out from this module. And I can convert that through the calibration curve that I have in my spreadsheet back into an RF input power that's being delivered to the module. One of the interesting quirks I noticed when testing this flight controller is if I take the USB cable and plug it in, because normally I would control the VTX using Betaflight over USB, the moment I plug in the USB cable, the VTX output power drops to 0. You can see it's just winding down now. And it will drop all the way down to absolutely 0 output. Then if I unplug the USB, you can see the VTX turns back on and the power jumps back up again. So if you're wanting to change your OSD settings, if you're doing that in Betaflight Configurator, you won't be able to see the changes that you're making when you make them, because the VTX will be powered off when you've got the USB plugged in. So you'll have to make the changes and then check. Let's look now at the results from the VTX power output testing. And starting on 25 milliwatts, we can see that on race 1, we're getting just about 10 milliwatts, up to about 20 milliwatts on race 8. And you can see that the output power increases as we go up the race band from channel 1 to channel 8. Moving up to the 100 milliwatt setting, anywhere from about 30 milliwatts all the way up to about 75, 76 milliwatts on race 8. And again, it's following that same trajectory of increasing output power on the higher race band channels. On the 400 milliwatt max setting, we are getting anywhere from about 160 milliwatts on race 1 up to very nearly 400 milliwatts, about 390 milliwatts or so on race 8. So again, it's varying. All of the set power settings actually behave very similarly. They all increase output power on higher channels, with the maximum output power occurring on the highest channel, race band 8. All right, now it's time to take this little Acrobee75 for a flight. And I would love to do that outside, so that we could show off a bit of the acro performance, but the weather is terrible today, so we're going to have to stay inside. I'm going to whoop it around the flat. I'm going to test it with a 420 and a 750 milliamp hour battery, so we get some idea of flight time on a smaller and a larger pack. And we can also see how the camera handles indoor lighting conditions like we've got today, and also I'll fly into some dark rooms so you can see the low light handling as well. So let me give you my thoughts on the flight. And overall, I think this little Acrobee75 flies really, really well. I wasn't able to push it hard in acro mode, obviously, because the weather is just pouring it down with rain at the moment, but it was really enjoyable to fly around the flat, and certainly the angle mode tune is really, really nice. I was able to get about 5 minutes of flight time on a 420 milliamp hour and more like 8 minutes of flight time on a 750 milliamp hour 2S battery. And I think that's fabulous. That's loads and loads of flight time. The drone was pretty controllable, pretty easy to fly, and had plenty of power and punch even with the heavier 750 milliamp hour pack. It was pretty easy to control altitude, no issues there. In terms of the camera, I thought the image from the Runcam Nano was pretty clear, the colors were reasonably nice, and it did cope quite well, I think, with the low light when I flew into the dark rooms. In terms of whether you prefer that style of image versus a camera that's maybe got a bit more saturation in the colors, it's going to be a personal preference, but certainly it provided loads of information to fly with. I liked the Newbeedrone OSD. The setup they have there is really nice and clear. There's lots of information, but it doesn't distract from flying. And I did notice it just flickered ever so slightly occasionally, but it wasn't enough to bother me while I was flying, but it's just something that I noticed. One thing that I did notice when crashing more than when flying is that with these larger 0804 motors and the 40mm props, the prop does protrude above the top of the prop guard. So if you are coming down on something and it's coming from the top, it is going to be able to touch the prop before it touches the prop guard. And that can, fling the drone across the room a bit, or potentially if you jam up a prop, it can cause the drone to kind of flip out. So just worth being aware that, you've got really good prop guard protection from the bottom and from the sides, but just if something is coming down from above, there's not much to stop it touching down on the prop there. So now it's time to sum up everything that we've learned about the Newbeedrone Acrobee75 BLV5. And I'm going to start with the things that I really like about it. I think the frame and the canopy both are very durable. I think even if you have some quite heavy crashes with this frame, you're very unlikely to break anything because it really seems very, very robust. I like the addition of the carbon fiber base plate. That's also going to add some rigidity and some durability to the design. And I like the battery mounting solution with this little flexible 3D printed part. It holds the battery really nice and securely and supports a whole range of different battery sizes, from anything from 450 up to a 750 or even bigger. You can fit in this little battery holder here. In terms of the camera, the Runcam Nano 4 is a really nice camera. I quite like the natural looking colors, and it has lots and lots of detail for flying and good low light performance. And that's everything you want. It's, you can tell just the nice big optics module here in this camera just gives you confidence you're going to get some nice clear detail. I like the OSD layout, and the quad flies really nicely. The stock tune is really good. And you can cruise around easily indoors and get some really, really nice footage with it. Now moving on to the areas where I think there's room for improvement. Firstly, the connections for the motors are plugged, and particularly for these larger 0804 motors on 2S, you definitely want them direct soldered because the plugs have a bit more resistance, and that's going to affect the overall flight performance, just reduce that power that you're going to be able to get from the motors. Particularly if you're wanting to fly outside and fly acro, then direct soldering the motors is going to make quite a bit of difference. But my biggest bugbear with this new Beebrain BLV5 flight controller is the lack of Blackbox storage. That's number one. It's really, really important to have Blackbox capability on your flight controller if you want to do any debugging, if you want to do any tuning, because without that kind of truth data of what the quad's actually doing, it's really hard to figure out what you need to change in order to make it fly better. The VTX on the Beebrain is actually, I think, a positive. The integrated VTX is working pretty well. It's a bit variable in terms of power output across the different channels, and it definitely produces more power at the higher channels like race 7, race 8 than it does on raceband 1, raceband 2. But in terms of power output, certainly the VTX does live up to its 400 milliwatt claim on the higher channels. So if you get up to race 7, race 8, it can reach up to that 400 milliwatts with good cooling, but it doesn't achieve quite that amount of output on raceband 1. So with all that said and done, who is the Acrobee75 going to be right for? Well, if you're a pilot who is looking for a fire and forget 75mm 2S tiny whoop, and you're not worried about doing any black box log analysis, then you're definitely going to want to seriously consider this one, because you're just going to get it, bind it to your radio, go and fly and enjoy it. And the default settings on this are really good straight out of the box. And if you have any issues, it's backed up by Newbeedrone's truly excellent customer service. So they're going to take care of you. If that's the kind of experience that you're looking for, then you can find links to where you can get hold of the Acrobee75 BLV5 down in the video description. And they are affiliate links, which means that if you click through on them and make a purchase, it does help support the channel and doesn't cost you anything. So please do try to use those links if you can. That's all I have for you for today. So until next time, I wish you all very, very happy flying.